Greetings and hello. Today, on behalf of Group 4, I would like to present our assignment for KEEE 2243 Instrumentation, which is the Smart Parking System. Before that, let me introduce our group members, which are Ooi Shi Shi, Safiuddin, Ung Tsu Han, Vicky Sim, Wan Yin, and me, Alexander Choo. This is the background information for the KEE 2243 instrumentation. Ta-da! This is our assignment, which is the smart parking system. Let me have a brief introduction for our assignment. The smart parking system is a system that is used to implement systematic parking. It helps to manage vehicles in a parking area in order to avoid wastage of time and labor. For example, shopping mall and even in our UCT. It implements counter-based system, which uses sensors to count the number of vehicles entering and exit a car park area. It has a gate arm, counters and pressure sensors, which are located at the entrance and exits. It gives information on the total number of vacant lots, but does not help much in guiding the driver to the exact location of the vacant lots. Next is the literature review. The car park inside a building is becoming more and more popular. This type of car park poses a parking guidance system. The availability of parking lots inside the car park normally is obtained from the sensors that count the number of cars entering and exiting. This information is sent to a computer that processes it, and availability is generally expressed in terms of full or empty. Our motivation for choosing this project is because the conventional car parking system does not have any intelligent monitoring system, and the parking lots are being monitored using human labor. This implies the use of indicators to show the number of vacant parking lots, accompanied by the gate arm counters to control the flow of vehicles into and out of the parking area. This system is done by carefully maneuvering the signals detected by the sensors located at the entrance and the exit. Taking the budget problem into account, our group decided to create some simple yet efficient pressure sensors using affordable materials such as aluminum foil, cardboard, metal paper clips, and wires, rather than using expensive and sophisticated sensors like ultrasonic sensors, IR sensors, induction loop sensors, etc. Next is the methodology of our assignment. Firstly, the Nuvoton ARM Cortex M0NUC140 is programmed using NuMicro Vision 4. A few crocodile clips are connected to the Nuvoton board to stimulate the pressure sensors. Realizing the digital signal is active flow. A source code utilizing the signals from the pressure sensors to control the LCD display and buzzer is written in C language. The project file is rebuilt, debugged, and ran on the Nuvoton board. Then, the Arduino board is programmed using Arduino compiler. A source code utilizing the signal from the pressure sensors to control the microservo motors is written in C++ language. The code is compiled and uploaded to the Arduino board. The base of the parking lot is built using 2 pieces of thin cardboards, 1 piece of thick cardboard, and 4 pieces of aluminum foils. The entrance and exits area of the parking lot are marked on one of the thin cardboard, which act as the lowest layer. 2 small pieces of aluminum foils are placed on both areas respectively. The thick cardboard is cut such that the entrance and exits area are hollow and then placed on the previous layer. Another 2 small pieces of aluminum foils are placed on the entrance and exit areas of the thick cardboard. Precaution is taken so that the upper and lower layers of aluminum foils will not touch one another normally unless pressure is applied on them. Another piece of thin cardboard is used to cover on top of all the layers and decorated into a parking lot, where the entrance and exit areas are marked carefully. All the layers of the aluminum foils are connected to the Nuvoton and Arduino board using metal paper clips and crocodile clips. Next, 2 microservo motors are attached to long paper rolls, respectively, to act as the barriers. They are placed at the entrance and exit areas accordingly, and then connected to the Arduino board with the aid of jumper wires and breadboard. 7 minicars are built using stapler bullets boxes or erasers as loads and decorated with color papers. The functionality of the system is tested, and the concept will be further explained in detail in the result part. This is the schematic diagram of the smart parking system. Basically, there are Arduino board and Nuvoton board. The Arduino board is used to control the two micro servo motor, which are the entrance servo and exit servo. The entrance switch and exit switch is connected to the pin 8 and pin 9 of the Arduino board respectively, whereas the pin 11 and pin 12 is connected to the entrance servo and the exit servo respectively. When a signal is received by pin 8, the pin 11 will cause the entrance servo to react and the motor will be raised up by 90 degrees to let the car enter the parking lot. Similar to the exit servo, whereby the pin 9 is act as an input pin and the pin 12 is act as an output pin. At the Nuvoton board, the entrance switch is connected to the GPA0 and the exit switch is connected to the GPB0. Generally, when GPA0 receives a signal, the number of available slots will cause the number of available slots to be increased by 1. For this project, the maximum number of available slots is 6. Next is the algorithm of the assignment. The source code of the Nuvoton board is available at the link below, but I will show you the real compiler of the Nuvoton board. This is the Nuvoton program. While the number of slots is between 0 to 6, while the number of slots is between 0 and 6, if the entrance sensor is on, the buzzer will sound for 1 second. And the number of available lots will decrease by 1, and the LCD screen will display the text shown in the program. The system is programmed to delay for 3 seconds to prevent it from picking up the signal too fast. Similar but inverse concept goes to the exit part. And next is the source code for Arduino board, and I will show you the real Arduino program. This is the Arduino program. We create servo object to control servo. We declare the pin connected to servo motor. When the switch pad is closed, the inputs equals to 0. So if the switch pad is closed, we still have available parking lot. Then the servo motor will turn 90 degree and delay for 3 seconds to let the car go in. After 3 seconds, servo motor turn back to original position. The available parking lot is deducted by 1. If the program don't have available parking lot, Arduino will not perform this action. Same goes to the servo motor at the exit part. Next is the flowchart of the assignment. The program of the smart parking system is based on the flowchart below. For our assignment, the initial number of available lots is 6. The car is detected at the entrance. If the number of available lots is more than 0, then the buzzer will sound for 1 second and the number of available slots will be decreased by 1, and the program will be delayed for 3 seconds. At the Arduino part, the Arduino servo motor will be raised up for 90 degrees and delayed 3 seconds and lowered. When there is no number of available lots, the car at the entrance cannot go into the parking lot. At the exit, when the number of available lots is less than 6, the Nuvoton LCD display will show that the number of available lots is more than 1 if the car is going out of the parking lot, and the buzzer will be sound for 1 second. The Arduino servo motor at the exit will be raised for 90 degrees and delayed for 3 seconds and lowered. If the number of available lots is 6 or more than 6, there is no action at the exit part. Next is the result of our assignment. Initially, when the parking area is empty, the LCD screen of the Nuvoton board will display the number of available parking lots as 6. When the car intends to enter the parking area, the weight of the car causes the switch pad at the entrance area to be turned on and a beep sound is produced while the number of available parking shown in the LCD display is deducted by 1. At the same time, the Arduino board also receives the same signal from the switch pad, causing the barrier at the entrance to be raised by the micro servo motor for 3 seconds to allow the car enter the parking lot. In case when the parking area is fully occupied, for example there are 6 cars in the parking area, the number of available slots will be turned to 0 and LCD display will immediately change to "Sorry, parking lot is full." The LCD display and the entrance barrier will not respond to the signal of the pressure sensor at the entrance area. The entrance barrier can only be raised when there is at least one available parking lot in the area. Next, when a car intends to exit the parking area, the weight of the car causes the switch pad at the exit area to turn on and a beep sound is produced while the number of available parking lot in the LCD display is increased by 1. At the same time, the Arduino board also received the same signal from the switch pad, causing the barrier at the exit to be raised by the micro servo motor for 3 seconds to allow the car exit the parking lot. The LCD display and the exit barrier will not respond to the signal of the pressure sensor at the exit area when the number of available lots has reached 6, which is completely empty in this model. Now I would like to show you of the beep sound. Now I will show you the actual demonstration of the smart parking system.
Danny, the king of the track.
We will now present to you the smart parking system.
Hi everyone, we are going to demonstrate our smart parking system which uses aluminum foil as a switch pad. The switch pad is normally off when there is no pressure act on it. When the first car approaches the entrance area, the weight of the car will cause the switch pad to be connected, acting as an on switch. This signal will be detected by the Nuvoton board, which then will deduct the number of parking lot by 1. At the same time, the Arduino board will receive the signal and causes the barrier to be raised up by the servo motor. As you can see, after the second car and the third car went through the barrier, the number of parking lot will be deducted accordingly. When one of the car wanted to exit the parking lot, and by using the same principle as the entrance area, the barrier at the exit area will raise by the servo motor and lowered after a few seconds, and the number of parking lot will be increased by 1. Now we are going to demonstrate to you what will happen when the parking lot is full. And the 7th car wants to enter, the barrier won't be raised and the number of the parking lot won't be decreased no matter what happens. Only when one of the car inside the parking lot exited the parking lot, only then the car outside the parking lot can enter. Thank you for watching.
Okay, next is the discussion. We have encountered a few obstacles during the process. Firstly, is the insufficient knowledge about the programming language of the microcontroller board. Next is the mistakes in the programming. We have to try and error, debug, and compile many times so that the program will run smoothly without an error. Next is the technical problem, the budget problem, and the time constraint. This system can be further improved by adding other functions such as reservation-based smart parking system and parking guidance information system to assign car to the nearest possible lot. Different sensor systems can be added to improve this system in order to detect the vehicles and guide the drivers more efficiently. And we have come to a conclusion. The smart parking system project was implemented successfully. The system was able to work as intended with some spaces for improvement. We are able to build aluminum foil switch pads that act as pressure sensors. And we are able to program the Nuvoton ARM Cortex M0NUC140 using C language to utilize the LCD display and buzzer to act depending on the input signal. Lastly, we are able to program the Arduino board using C++ language to control the micro servo motors to act depending on the input signal. At last, thank you so much.